to answer a question that somebody asked from my previous video, and the question was, where does the faulty current go? But before I explain that phenomenon, let me explain a very simple phenomenon that had happened with this equipment, a phase tester. A phase tester. This is an electrical equipment that when you touch the live wire while touching the base over here, it has an LED inside there that light up if that place that you have touched is live. So the question is, how does a phase tester work? So let's look at that. So you have a live wire, then you touch with a phase tester, you yourself, you touch here, and boom, the LED here starts showing. So how does that happen? The LED inside there cannot show if the path is incomplete. So that means when you touch the live wire, let's say the live wire is at 200 volts, mainly 240, 200, that thereabout. So there is always a resistor connected in series with that LED. So there is LEDs over there. Then you touch around this place. Then the phase tester touches the line, and this LED glows. So basically, this one is to tone down the amount of current that, or rather, to create a voltage drop so that the voltage that you're touching here is safe for you. So how does it actually work? So what happens is, this is the live wire. The phase tester is here, the resistor is there, then you have your LED here, then you touch here. So basically what you do when you touch this place, you create a return path. All right, so electricity passes through this one, through you, then through the ground, and the return. That is to say that whenever you touch that line over there, some current actually flows through you to ground to enable the LED to show. So what does that tell you? So to respond to the question, where does the faulty current go, let's look at the electrical circuit. So you have the source, and the source is connected to ground. So at the source is connected to ground. Then this source supplies you up to, there is a lot of things here. There is a substation, blah blah, the stepping up, whatever, stepping down, substations and all of that. Then it comes to the final transformer, which is in your neighborhood, like that. And in this transformer, we said that there are 4 wires that are coming out of it: the star point, the one phase, the other phase, and the third phase. So this neutral line here is also grounded. So theoretically, rather, the earth mass provides an alternative return to current from the loads and from the transformer back to the source. So whenever that happens, it forms a complete electrical path. That's why the transformer is functioning fine, and the source is also communicating with the loads just fine. So, and again, after the transformer now, after the TX here, the neutral wire is grounded. Then, as we said, at the intake point again, the neutral wire is also grounded. And the appliances in your house, the loads, are also grounded. So the electricity that is faulty, that for that case, the live wire touches the casing, is supposed to travel back to the source. And that happens through this common conductor, and that common conductor is what we call the earth. So the electricity doesn't just disappear in thin air, rather it travels back from your load. Either it travels back to the source, okay, it travels back to the source either through this cable, the neutral cable, so that the path will be complete, or in case there is a faulty, now that it is now shared between the load, the neutral, and the earth wire, the earth mass serves as the return to the source. So as I said, the reason why the earth cable protects you, the earth wire protects you, is that it provides an easier path to return to the source rather than using your body. So the phase tester scenario explained to you that there is some current that is flowing through you to ground. All right. So the earth mass, sorry, is a return path to the source. That's why the phase tester works. So the earth wire is to provide an alternative path back to ground, but this time the conductor is the earth mass. But when you are in contact with the earth mass together with this wire, you are. So let's look at this way. The load is here. So the load is grounded, and you are also standing in the ground. As we have seen from the first test scenario, you also some current is flowing through, and some current is flowing through this cable. So in case this one is touched by a live wire, so you like, okay, the electricity is going to take the path of least resistance through the RF cable rather than your body. I guess you understand now basically where the return current goes. It doesn't disappear in thin air, rather it travels back to the source through the earth mass.